Example 4 is going to be doing average rate of change. Here's example 4. Please write this down. We are going to have a function. And then there is a lot that we should recognize in our heads without ever looking at a picture. First of all, this is raised to the odd component for an exponent. That means it's going to have opposite in behavior. Also, look, they both have x's. I know it's going to go through the origin. Last but not least, you have a leading negative. Remember, if you have a leading negative, it is down on the right-hand side. So what we're going to do is we're going to analyze the average rate of change. Change in y over change in x. But you have to be given a domain. So here's part of what's given to you. We're going to analyze from a -3 to a -1. That is the domain given. Remember, that is an interval, and that is x values. It is so easy to find the average rate of change. Here's your steps. Step 1, find the outputs. Step 2, change in y over change in x. That's how easy it is. All right, here we go. I got to find the outputs based on these inputs. I'm finding 2 outputs based on that, based on that. Here we go. So I'm going to plug in my input of -3. I am going to use parentheses because I'm scared that I'll lose a negative. All right, so when I plug this in, -3 times -3 is a +9. +9 times 1 more -3 is -27, but you have a negative right there. So -27 with that negative is +27. And then this is just minus 3 for the input. I forgot to put my 3 right there on that. That was already part of that problem. So a +3 times my input of a -3 is going to be a -9. So when I have an input of -3, I have an output of 18. X, Y. X, Y. All right, find outputs. See, we wrote outputs with the letter S because we're not done. Now we got to do it for -1. But I'm just going to put a bubble around this because this is like so important. I don't want to lose that. I'm at the edge of my paper. I'm scared I'm running out of room. All right, here we go, -1. So I'm going to use my parentheses, drop in my other x value. Do my little math here. Here we go with -1. -1 times -1 is +1. +1 times 1 more -1 is -1 times a negative on the outside. This is a positive. A 3 times a -1 is a -3. So it looks like my output for this, when f of x is a -1, we have a y value, we have an output of -2. That's the x, like these. That's the y, like those. Now, here's where the beauty happens. I'm just going to do this in my head, understanding this concept. So the first number in the interval was -3. So if the first number in the interval was -3, then that's where it starts. It starts right here. -1 is where it stops. All right, look. The y's are first. It started at 18. It ended at a -2. That's a giant decrease. 18 down to 0, then 2 past that. So 18 all the way down to a -2 is going to be a giant decrease of 20. Think about a number line. I'll draw it right here. Here's 18. Here's 0. Here's -2. Big giant decrease of 20 steps. All right, that's my change in y. Done. Now let's figure out what happened to the x's. Where did the x's start? Read it like a sentence from left to right. It started at -3. Okay. It increased a little bit, not a lot. It increased from a -3 to a -1. That is an increase of 2 places. So this is going to be a +2. So my x values increased, my y values decreased. -20 divided by 2 is going to be my answer. That's going to be a -10. That's nice that we got a clean, easy whole number. Sometimes it's not like that. Now, since I have a negative value, then it should be mostly, now remember, I'm not looking at a graph, but it should be mostly decreasing. And we're going to check it. Let me show you Desmos. So I'm going to plug this in on Desmos so fast. Watch how fast I did this. Here it is right here. Now, if you notice these vertical lines, guys, I just put these vertical lines here just so you can kind of see the boundary where we were looking. Oh, that was a -1, excuse me. So this section right here is the section that we are looking for. And if you notice, that is a giant drop. So it makes absolute perfect sense that our absolute or our average rate of change for this function is decreasing. Look, does this graph go through the origin? Let's see. It sure does. The origin is right here. But you already knew that because it had both x's. Look, you got opposite in behavior. This is going up forever. That's going down forever. But you knew that because it was raised to an odd exponent. One more thing, please don't forget. If it has a leading negative coefficient, which it does, see the negative in front, it's always down on the right. Such an important concept to remember.